Hello, guys. Just wanted to talk through a couple of things for the day today. First, it's a reminder. You've got your carbon cycle quiz corrections. They're optional. They're due tonight by 11:59 p.m. So please make sure you go back, follow all those directions to get those points back. Otherwise, I wanted to spend a little bit of time talking through the water cycle and human impact. So we have our diagram here. I'm going to change some colors here real quick. I think the biggest thing when it comes to the water cycle, because you've seen it so many times, are some of the new little details that we've added here for you. And I think the first and most important detail is what are the two drivers of the water cycle. And really it comes down to the sun and really, it's energy, not the sun itself, but energy from the sun and gravity. Those are the two biggest players when it comes to the water cycle. So for example, if we start down here in a body of water, could be a lake here in Minnesota, could be the Atlantic Ocean. Energy from the sun is going to heat up or transfer that energy to the liquid water, break the bonds between those water molecules and allow that water to turn into its gas form through evaporation. Okay, so prime example of the sun being a driver. Condensation can be a little bit tricky to think, well, how is the sun or gravity causing that? And for that one, you need to think about energy. And in this case, we know that as we move further and further away, as we go up in the atmosphere, this is from our climate unit, further and further away from the surface, up here, it gets colder. So again, it kind of goes back to energy. So up here, as that warm, evaporated gas, water goes up into the atmosphere, it will cool because there's a lack of energy now and condense to form our liquid water in the clouds through the process of condensation. Okay, from there's three processes that are completely driven by gravity. Eventually that liquid water in the clouds gets too heavy to stay up in the atmosphere, and we get precipitation. Okay, gravity pulling that liquid down back to the surface. Okay, from there, once it hits the surface, it has two choices. You've got runoff. Again, runoff is dealing with gravity, so pulling water from high areas to low areas. The thing to remember here is that runoff is completely on the surface. Okay, runoff surface, whereas the other gravity-driven process is this process of infiltration, right? The beginning of this word is extremely important to help you remember what the heck's going on. So when that precipitation hits the surface, some of it will infiltrate or go into the ground and restock the groundwater. Or sometimes this infiltrated water will get back into larger bodies of water. Okay, so precipitation, runoff, infiltration, completely gravity-driven. The last nuance here is transpiration. Some people call it evapotranspiration. To me, sometimes that helps because we know that evaporation, we know what evaporation is. It's just turning liquid water into gas water. If you add that evapo to transpiration, it kind of helps you remember what's going on. So again, in this case, we're taking liquid water into gas water, same process due to energy from the sun. But now it's happening on or in the leaves of vegetation. Okay? So that should take care of our little review. Again, remember sun or energy, gravity are our two drivers. That's all review. Okay? When it comes to why we're talking about the water cycle, it goes back to the carbon cycle and not just knowing what the cycle is, but also how are humans impacting it. And there's a few things here in this diagram that I want you guys to understand when it comes to human impact. And it is how changing the landscape impacts where that water goes. And what impacts does that have on ecosystems, but also what does that have an impact on us? So if we start here in a natural ground cover environment, when it comes to precipitation, in the water cycle, when it rains, 50%, so I'm taking the 25% shallow, 25% deep, 50% of that rain will infiltrate into the ground, okay? Which means you only got 50% left to do other things. Well, in this case, if we take a look at natural ground cover environment, well, that 50% infiltration, a lot of that goes back up into the vegetation, where that vegetation then can do evapotranspiration, okay? So it's kind of staying all in the same area. Only 10% is running off and going somewhere else, okay? However, as we move over to the right-hand side of this diagram, ultimately ending at a 75 to 100% impervious surface. Remember, impervious means does not let through. Okay, so all these surfaces, these buildings, the roads, sidewalks, are all impervious, which means that it doesn't allow things to go through. In this case, the thing that we're talking about is rain or water. Okay, so just imagine taking a grassy area here in Minnesota, all the way over here on the left-hand side, and somebody coming in and developing it and turning it into a strip mall or developments or places for people to live. Okay, now what that's going to do, since we're adding more and more impervious surfaces, is we're going to increase the amount of runoff, right? Because if that surface down here is impervious, well, it can't get into the ground, right? So we're going from 10% runoff over on the left-hand side, natural ground cover, all the way up to 55% runoff, okay? 15% infiltration and 30% evapotranspiration, okay? Well, what are the consequences of doing that, of increasing the amount of impervious surfaces and increasing the amount of runoff? Well, if you don't know, a lot of communities, a lot of cities depend on groundwater. So it depends on this infiltration, okay, because what we do is we drill wells down into the groundwater, and we pull that out of the ground, and we use it to drink and wash our whatever we're washing. Okay, so if we are increasing the impervious surfaces, ultimately we're hurting ourselves because we're potentially running out of groundwater that we need for our everyday lives. Okay, now if that water isn't getting into the ground, it's running off. Okay, so it's staying on the surface. And in big cities, or just regular cities, I guess, there's a lot of stuff, a lot of junk on these impervious surfaces, from litter to chemicals, right? Your car is sitting in a parking lot and it's sitting there with hundreds of other cars. Well, those cars are probably leaking different chemicals like oil or gasoline or antifreeze or whatever the case is from their car. Well, that's going to sit there on that impervious surface until it rains. And then once it rains, it gets picked up by the rain and moves into, runs off into bodies of water. Okay. What we'll also learn about here is if we have more runoff, especially now in the springtime, people are putting fertilizers and things on their lawns. Well, a lot of that's going to run off into bodies of water, and when we get into the nitrogen cycle, you'll see why that's a problem. Okay, so taking things from natural ground cover where we're getting a lot of water staying in that place to moving over to impervious surfaces and water not staying in that same place has a lot of consequences. Okay, so I just wanted to spend a little bit of time talking through those two things. What you need to do for the rest of the day today is work through your learning target summaries. Okay, so if I go back here and I take a look at my learning targets, I'm going to see that learning target 1, 2, 3, and 4 all deal with the carbon cycle. So you should be done with those. If you're not done, please take some time. We don't have a lot to do today. Take some time to get those 4 done. Otherwise, when we take a look at learning target number 5, those are the processes for the water cycle. You should be able to do those today. Learning target 6 is the diagram that I just went through, so you can label and this diagram, make sure your arrows and everything is labeled correctly. And then learning target number 7, you should also be able to do based on what I just got done talking through. Okay, so that is something that you could work on for the day today. Otherwise, I want you to understand that this water cycle learning target is really not about the cycle itself, because it's a lot of review. What we're really focusing on is human impact. All right, so what I did in my cycles folder is I put a water cycle human impact discussion. Okay, I put it in my upcoming. Okay, so when I take a look at this, there are 3 things to do. Watch this video right here about human impact. What I like about this video is not only does it tell us what's happening to environments because humans are impacting it, but how we can reverse those impacts. Okay, so watch that video. There are 2 questions to answer. To do that, you're going to hit after you've watched the video, hit the discussion tab up here on the top, and then hit the plus button in the upper right-hand corner and answer those 2 questions. Okay? And then when you're finished, take a look at what some of your classmates are saying, and then if you'd like to respond, please do that. Okay? Otherwise, that's the plan for the day today. Have a great day.